Hey, it's Randall. This will be the first video introducing you to Fusion360. This video will be dedicated to introducing you to the general user interface and simple building tools for making parts. The video after this will be assembly, and the video after that will be rendering. So without further ado, let's jump in. What you see here is the view that you'll see when you open up Fusion360. What you see here is your viewport. When you are creating sketches or objects, this is where you'll see them. To move around the viewport, to change orientation, you can click and drag this box and it'll change the orientation from which you're viewing the object or objects. You can click your mouse wheel and drag to move the entire viewport without changing your orientation. Down here you have the various tools which you can use to modify your viewport to your specifications. I tend to just keep it default. Up here you see tabs for your various projects that you're working on. At the moment I'm currently only working on one, but I could create more by clicking the plus sign and delete those projects by clicking those X's, so long as they don't have anything in them. If you just click those X's and there is something in them, it'll just close your instance of the object, but it won't delete the object. Moving along, here we have the save button, undo, redo, and file. The file tab is like most editing software, whether it be a word processor or a video processor or whatever. These dots here open up your data panel, and from here you can access the various folders that you will be working in. This series of videos will be using the CAD training folder, and you can create new folders if you wish to. Now, to get started with building or designing, you're going to be using the Design tab here, and these are the tools you'll be using. To start off, in this video, I'm going to be building the parts that you will generally need for a PDR launch vehicle. I'm going to be basing it loosely off of the launch vehicle that we designed last year. It won't be exactly the same. I'll be using a little rounder numbers, but the design will be generally the same. So we'll have the booster section, the payload tube, Bay, payload bay, coupler, engine enclosure, centering rings, fins, and nose cone. So I'm going to start with the booster section, and specifically the hull for the booster section. So to do that, I'm going to create a sketch, and you click that and you'll be given the choice of on what plane you want to start sketching. I'm going to choose the top plane because I generally use the top plane to give all of my objects a common orientation. That just makes it simpler to arrange them in the assembly step, which will be next video. So now that we've created a sketch, we can start drawing in it. And since the booster section is just a tube with some holes in it for the fins, again, this is the PDR, not the CDR version. I'm going to draw a couple of circles. The first one is going to be the outer diameter of the tube, and the second one is going to be the inner. The outer diameter, which we used last year, was 6.17 inches, so I'm just going to say 6.17 inches. And the inner was 6 inches even. And to create a solid using that, we're just going to go back over to solid and click extrude. And for the profile, we're going to select this outer ring here. I'm going to extrude it only in one direction. I could extrude it in two directions or symmetric in two directions, but one direction works for me. And I'm going to say 45 inches, which was roughly the length of the booster last time. All right, now we've created a solid, and if we look here and zoom out, there is our tube. Well, now we've got the tube we'll be working with, but how the heck do we fit the fins in there? Well, we cut some holes. How do we do that, you ask? Well, it starts with another sketch. And for that sketch, I'm going to choose, I'm going to say the front pane. No real reason for that. I could have chosen any of the planes orthogonal to the top plane, but I just decided to use front, because why not? Now that we've done that, we're going to create a rectangle. And there's a rectangle tool here. There are a few different types of rectangle tools. I should have gotten into that with the circle, but you can click this drop down and you'll see the various types of shapes that you can use. But for the fins, we're just going to create a rectangle. And I'm just going to use the default 2-point rectangle. And I'm just going to throw that here. It doesn't need to be centered at the moment. It will be in just a second. Then I'm going to create a line and draw it from the origin. And I should have noted this using the circles earlier as well. If you click a point at the origin, it will define that point to be at the origin. And I'm just going to draw that up to that edge. And since I clicked the center point of that edge, again, like the origin, it defined that point as being the center point of that edge. But to make it even more definite that that is the center between these two edges, I'm going to click Symmetry, select these two edges, and select that. And yeah, so it's over constrained, but that's all right. I can just Control Z that, since that is a center point. If it were not a center point, if I had just sort of drawn this and not connected it to the midpoint of that edge, I would have had to create a symmetry about this center line. Now, to define how far away that bottom of the rectangle is from the base of the cylinder, I am going to use sketch dimension, and I'm going to select this line, and I'm going to say it's going to be 2 inches away from the bottom. And now you see how that line has turned black. That means that it is fully defined. However, to fully define the rest of this, we're going to have to define how long this line is and how long these lines are. Fins that we designed last time, the plexiglass fins, not the, or not plexiglass, it's the fiberglass fins that we used, not the wooden ones, were 1/4 of an inch. So I'll just say 0.25, not 25 inches. Oops. But that's simple enough to change. 0.25 inches. There we go. and their height was 12 inches. And now we're going to do a very similar thing as we did to create the cylinder itself, now that that is fully defined. And we're going to go over to solid, extrude once again, and instead of new body, we're going to select cut. And instead of a set distance, I'm going to say through all. That's not always the best choice if you're working on a fairly complex object, where if you were to create that through all cut, it would cut through different parts of the object that you're working on. But since this is a fairly simple shape, we're just going to say through all. And OK. And there's our first fin hole. Well, that's all well and good, but how are we done to get the other three? We could go through that procedure once again for all three of them, but there's a much simpler way to do it. And that's just to click this Create drop down, find pattern, which is here, circular pattern, and instead of faces, we're going to choose features. We're going to click one of the inside edges of this cut. That selects the entire cut feature. For the axis, just select one of the circles. I'm going to choose the outer diameter of the hull, or outer circumference of the hull. And for quantity, I'm going to say 4. And there we go. There's all our fin holes. And that is the completed hull for the aft section of, or for the booster section of the rocket, which is the aft section of the rocket. And to save it, just Control S, name training booster skin. Could say hull, could say whatever, tube, doesn't really matter. As long as you know what it is, as long as everyone else knows what it is, that's fine. I'm going to take a drink of water. 1 moment. And now for the next part. For the next part, we are going to create the parachute tube, which is exceedingly simple. Oh, and I should note that for the CDR, you would have to add in the bolt holes and that sort of thing. For those holes, you can just follow the same procedure that we did for the fins and just make circular holes according to the diameter of whatever bolt or pin you're going to be using. So now for the parachute tube. Again, start a new sketch, draw a couple more circles, centering them on the origin, and once again, define this one as 6 inches, and should have made that a little bit further away, and 6.17 inches, and solid extrude, click that outer ring there, distance, and I'm going to say 30 inches. And just to make sure everything worked well, we're going to change the view. And yep, that looks about right. And save that as training parachute hole. Actually, I used skin for the other one, so I'm going to use skin for this one. Next will be the payload tube, and to its top, and again it's just going to be a simple cylinder. So again, sketch, circle, circle, define 6.17, define 6. So again, we're using the sketch dimension tool. solid, extrude, ring, and this one was 25 inches, and voila. And that is the correct view. Save. Training. Payload skin. And next will be the, I'll say coupler. And the coupler goes between the parachute tube and the payload tube. Now, I'm just going to rename these. I'm getting kind of tired of the word skin. It just sounds a little weird. So I'm going to go in here, right click, rename, booster, tube. Oh. Forgot to click enter instead of clicking away. Fusion is sometimes a little finicky about that. Rename. And you'll see how easy it is to modify these things. A little too easy, especially if you accidentally click away. Payload tube. I should follow my own advice and not click away. There we go. Now they're all tubes. And coupler, again, is going to be a simple cylinder. So, couple of circles, define this one to be the inner diameter of the hull, which is 6 inches. And since it's going to be made of the same stuff, it's going to be, the inner diameter is going to be 0.17 inches smaller than the outer diameter. So 6 inches minus 0.17 inches is 5.83 inches, so 5.83. Solid, extrude, click the outer ring, and the coupler has to go 1 caliber or 1 inner diameter into either side that it's going into. So that's going to be 6 inches on each side. I could define it as 12 inches, but I'm going to introduce you to the symmetric function, which is just distance times 2. And measurement is for one side. You can choose for one side or the whole length. I'm just going to say one side. And that's going to be 6 inches. And voila, we have a 12-inch coupler. 6 inches for either side. Save. Training. Coupler. Next will be the Avionics Bay. Again, this is a cylinder, but this one is going to be interesting because it's going to have a ring around the outside. But to begin with, let's just create a solid cylinder this time instead of a hollow one, which is even easier to do. Just define a single circle, and that's going to have a 6-inch diameter because it's going to be going inside the other tubes. And extrude, chooses that whole face. And I'm going to say symmetric, and it's going to be 13 inches all around because it's going to have a 1-inch switch ring in the middle and then 2 6-inch sections that will be going in, 1 into the parachute tube, 1 into the booster, or booster section. So we're going to say 6.5 inches, and there we go. And now for the ring around the middle, create another sketch, choose the top pane, start another circle at the origin, draw, and make that the outer diameter of the launch vehicle. And it chooses that entire face when you click extrude. And again, I'm going to say symmetric, one side symmetric, and 0.5 inches. And now that we look at it, oh no, it cut a hole. Well, what can we do about that? We could undo everything we did and start that middle section again, or we could go down to the timeline here, double click our extrude, and oh, that's what it did. It did a cut instead of making a new body. So we can just say new body, and that resolves that problem. You'll find that happens a lot if you're rushing and not thinking about it. It's fine. You can just go down to the timeline and undo or redo or change anything you've done. It's not that hard. So save that as training AV Bay. And now, for one of the most fun parts to design, the nose cone. So for this one, we're actually not going to be doing an extrusion, but we are going to be starting with a sketch like everything else. Instead of starting from the top, though, we're going to be starting from one of the planes orthogonal to the top plane. I'm going to choose the front. And we are going to choose 2-point rectangle. Doesn't matter how you draw it as long as one of the points is on the origin. And we are actually going to trim off those two arms of the rectangle. And instead, we are going to make a center point arc, which is down here under arc, and it's this second one down. Now I'm going to put this center point out here. Doesn't matter where you put it, as long as one of the points of the arc is on that point, and the other point of the arc is going to join up with that line. And to do that, just click coincident, click that point and that point, and they are now connected. And see how this center has shifted down? We don't want that to happen. So we're going to, again, use the coincident tool, which you should already still be in. Click that center point and click this line, and now see how that lines up beautifully with this lower line. And now we have an ogive. An ogive is just a section of a circle. That's not like, well, I guess it could be a quarter or a half of a circle. It just, this is a tangent ogive, so it's connecting at where if you put axes in the middle of the circle and one of those axes went through the circle, it will be at that intersection point, or if you know some simple calculus, it's just at the point where the tangent of the circle is undefined. Now, we need to define these two lines to make it match the specifications that we need for our nose cone. Which means this here needs to be half the diameter of the payload tube, or just the outer hull of the launch vehicle, which is half of 6.17, which is 3.085, so 3.085. And for this one, last year we used an 18-inch nose cone, so 18, and there we go. And now to create a solid out of that, instead of extrude, we're going to use revolve. It's already chosen the profile, which is just that face there. For the axis, we're going to use this center line and 360 degrees, and voila, we have the outer bit of the nose cone. Now we need the the bit that'll be connecting it to the rocket. And that's just a simple cylinder. So choose the bottom of the bottom face of the nose cone we just drew and created. Draw a circle centered at the origin, sketch dimension for that circle, and 6 inches, considering it's going to be fitting into the payload tube. Solid, extrude, choose that face, and it's pointing down, which is good. That's how we need it to go. And I'm going to say 4 inches, because that's what we did last year. It should really be 1 caliber, but we got away with 4 inches last year, so I'm going to say 4 inches. And there is our nose cone. Save. Training nose cone. Now we only have 3 more pieces to design. The dummy motor, the motor enclosure, and 4 pieces. I always forget about the centering rings. So the dummy motor, the motor enclosure, the centering rings, and the fins. So for the dummy motor, it's real simple. We're just going to create a cylinder that is the size of the motor we're going to be using. I'm going to be basing it off of an L1150, which has a 7.3 centimeter width and a 53 centimeter height. And there we go. There's our dummy motor. So save. Training motor. And for our next trick, we're going to make the enclosure for that motor. So it, just like many other things in this design, is a hollow tube that's going to be the same height as the motor, but the inner diameter is going to be the diameter of the motor, and the outer diameter is going to be that plus 0.17 inches. So first thing I'm going to do is define the inner as 7.3 centimeters, like that. And I've already found the outer diameter, doing a little bit of math before this, so it's going to be 3.044015748 inches. And again, solid, extrude, outer ring, and 53 centimeters. If this thing will actually select that. There we go. 53 centimeters. And there is our motor enclosure. Save. Training. Motor. And enclosure. Now for the centering ring, it's just going to be a washer. So sketch on the top pane again, 2 circles, because that's all a washer is. It's just a hollow cylinder. And this is going to be the diameter of the motor enclosure, which again is 3.044015748 inches. And the outer diameter is going to be the inner diameter of the hull of the rocket, which is going to be 6 inches. And solid, extrude that, and I'm going to make it the same thickness as the fins are going to be, which is 0.25 inches. 0.25 inches. Because I'm assuming we would be making them out of the same material. So save. Training. Centering ring. And then finally, we design the fins. And I'm going to design the fins on the right plane. And just the reason that I do that is because the original hole that we made for the fins in the booster section was facing towards the front. So if we draw the fins facing towards the front, that just makes sense in my head. No real reason for it. You could draw it on any plane. So I'm going to draw a rectangle, 2-point rectangle, with one of the points at the origin. This is going to be 12 inches. And the whole thing is going to be the 6 inches that the fin is going to jut out of the side of the rocket, plus the 3.125984.252 inches that are between the outside of the rocket and the outside of the motor enclosure. To find that, you just subtract the diameter of the radius. Sorry. I did the math wrong, so it's not the number I just said. You subtract the radius of the motor enclosure from the radius of the the outside of the rocket. So it's actually half the number that I just said. So pay no attention to the man behind the curtain. That should be 1.562992126 inches. So and then plus the 6 inches that it's going to be jutting out is 7.562992126 inches. Now I'm going to draw a line here, and it's going to be, it's already defined as perpendicular to this, so that's good. I would have had to have defined it as perpendicular using this, but it already did it for me, so that's fun. And that is going to be the 1.56299 2126 inches that the thing's going to be sticking into the rocket. And then a couple more lines like that, and like that. And I'm going to make a center line here. And that's midpoint already decided by the computer and perpendicular already decided by the computer, so computer is your friend most of the time. And I'm going to say that these two lines are symmetric about this line here. So symmetric. These two lines, and like that. And then I'm going to define the distance that these are away from each other, 6 inches. And now that that's fully constrained, I'm going to go over to solid, extrude, and that's going to be 0.2, not 25 inches, 0.25 inches. And there is our fin. Sometimes the computer doesn't like me. Save training fin. Now we have the booster tube, payload, parachute tube, payload tube, coupler, AV bay, nose cone, motor, motor enclosure, centering rings, and fin. And it is quite applicable that that is called fin because that is the finish of this video. Thank you for watching. The next video will be on assembly.